All right, friends. Hello. I hope that day one of drawing Lewis structures went well. I did look over the homework that was submitted, and I did see a few things that I wanted to talk about before we dive into something new today. So our warm up here is to draw this Lewis structure for CH2BR2. So we will do that in just a minute. But first, um, just some basic things. When we are drawing a Lewis structure, typically there is a central atom, and you have to pick what that is. And then the other elements are joined and bonded to that central atom around the four corners. So some people were like making long chains of elements like this. And we really don't see that. There are some hydrocarbon chains that we will see later, but most of these, actually all of these will not look like that. There could be all right, friends, I did want to, hi friends, I hope that your first day of drawing the structures went well and you are ready to learn something new and kind of add on to that skill today. We're going to start by drawing the Lewis structure for CH2BR2. So as I work today, I would recommend that you pause the video from time to time to give yourself time to draw the structures before I do, and then press play to see how I've drawn it. And you're then verifying, did you do it correctly? Or, ooh, now you understand what you did wrong because I'm explaining it as I do it. Okay, so I would pause and try to do this one before you see me solve it. Before you pause, though, I do want to say just some general things that I noticed yesterday. So there were a lot of people who were making long chains of different elements, and then the valence electrons are all around here. We really don't see that. We do see some hydrocarbons sometimes that form chains, but for now you will not see a structure like that. So when you have different elements, you have to choose a central atom, and then the other atoms are bonded to that central atom. So some people did not pick a central atom. Also remember, most atoms want 8 valence electrons. That is the octet. So you want to look to make sure that each element has 8, unless it's hydrogen, which is happy with 2, a duet. Okay, so that's your last step always. I did see that there were a lot of mistakes on that. So just going back and making sure that everything was satisfied, you'll want to make sure you do that. Okay, so let's just try a practice. And we said we were going to do CH2BR2. All right, so again, as I told you yesterday, you really need to go through the steps, step by step by step. If you do it step by step, there's really no way to get it wrong. Unless you just don't know how many valence electrons something has, in which case you need to ask your neighbor. Look in one of the many periodic tables I've given you that we've labeled to see that. Okay, so total number of valence electrons for CH2BR2. So carbon has 4 valence electrons. It's in group 4. Hydrogen, there are 2 of them, and each of them have 1. And then bromine, there are 2 of them, and each of them have 7 because it's in group 7. And then we need to add that up. So 14, 15, 16 is 20. 16 plus 4. Okay, so we have 20 electrons for our structure. My next step is to determine the central atom. So it's typically the first element. And there are some exceptions. It can never be a hydrogen because it can only bond one time. It can never be a halogen, again, because they can only bond one time. So usually it's the first thing, and it's really always the one that can bond the most. So the fact this only has 4 valence electrons means it can form 4 bonds. That's the reason why carbon makes so many different compounds on the planet and in the universe. Okay, so carbon in this case is going to be our central atom, and then everything else goes around it. Again, we're utilizing these four corners like a box. Okay, so there will be things coming off of each side. It doesn't form like a pyramid or something like that. Sometimes I see students try to do that. So I have carbon, and then I can put 2 hydrogens and then 2 bromines. Does it matter if you put bromine on the right instead of left? No. Okay, but there should be those 4 around it. Okay. My C is a little bit too big. All right, now my next step says connect all the atoms to the central atom using a single bond first. So I just connect everything. Each line is equal to 2 electrons. So I'm subtracting a total of, we've got 2, 4, 6, 8. So that means we still have 12 electrons left for our structure. All right, so the next step after that is to subtract bond. We did that. Then we complete octets and duets for all these peripheral atoms. Okay, hydrogen again is happy with 2. So once they bond, that's it. I did see a lot of people putting valence electrons on hydrogen. That will never, ever, 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 ever happen. Okay, because once it bonds, that's it. And then boron is an exception as well that you saw on last night's homework. So I need to complete those octets and duets. I have 12, okay? I add them always in pairs because you're never going to see a lone ranger out there, one by itself. You'll know you've done something wrong adding your electrons if you have one by itself. So 1, 2, 3, 4, 5, 6. That completes the octet for bromine with the bond there. And then the other 6 are going to go on this bromine. So then I have none left. If I did, I would put them on the central atom, but again, in this case, I don't. And then my last step is to see, do I need multiple bonds? So are the octets and duets satisfied for everything? So this hydrogen has 2, it's happy. This hydrogen has 2, it's happy. This bromine has 8. Remember that line is 2, so it's happy. This bromine has 8, so it's happy. And then the carbon in the center has 2, 4, 6, 8 as well. So all the octets and duets are satisfied. So now we know for sure that our structure is correct. Okay, if that doesn't make sense, please email me. Go to the ILC or ELC. You'll have to get help this week since I won't be around for another week. You will have to get help as you go from someone who knows what's going on. I'm happy to help you if you email me from home, but you might need more immediate hands-on help than I can give you for the next week. Okay, so make sure that you turned in yesterday's assignment. There, I did post a key for that as well. So before you attempt today's assignment, it's important that yesterday's assignment makes good sense to you. Okay, because today we're going to add on to this, and we are going to do some polyatomic ions. So polyatomic ions are, maybe I'll just show you that. So okay, so this is today's assignment, drawing Lewis structures day 2. So you do all the same steps that we did yesterday, only you're going to add on a couple of other steps. Okay, so again, yesterday needs to make really good sense. You will want to have all of those steps with you from yesterday as you work through today's examples as well. Okay, so today we're going to add on, some of these will be polyatomic ions. So what exactly does that mean? So polyatomic, poly means more than one, and then atomic is atoms. So more than one atom that act together as a unit. The fact that it's an ion means it has a charge. So we have positive ions and then we have negative ions. And they become ions by gaining or losing electrons. So if you see something down here, like the example we're going to do is carbonate is a 2- charge. We get a negative charge by adding that many electrons. So we've added 2 electrons here into this structure to make it work. Okay. Then there's also positive ions called cations, and they become positive by losing electrons. Okay. The only difference really when we're drawing these structures is that we have to take into account this charge with our total number of valence electrons. And then we also need to draw brackets around the final structure. So not too different from what we did before. Again, just really adding on to that. All right, so I'm going to do this one actually in this document here because I think we need all of these steps. Okay, so total number of valence electrons we're going to do first. Okay, so carbon has 4 valence electrons. I'm going to use a different color. Carbon has 4. Each oxygen, there are 3 of them, and each oxygen has 6. And then the fact that this is 2- again means we add 2 electrons because otherwise the structure will not work. So you'll know that you've forgotten that step when you don't get a number that makes it possible to satisfy the octets for everything. So this is a total of 24 electrons. All right, then we need to determine the central atom just like we did yesterday. Typically it is the one that's written first, and if it's carbon, you best believe it's going to be carbon. Okay, so we're going to put that carbon in the middle, and then we have 3 oxygens around it. Please don't try to make, like some people try to predict what the geometry will be later. Please don't do that. Just go on the 4 sides. So we only have 3 things bonded, so they're going to be on 3 of the sides. You don't want to make it like, oh dear. Sorry, it like does a weird zoom sometimes. You don't want to do like carbon and then oxygen, oxygen, oxygen. Like eventually, maybe that will be the shape, but that is not how we're going to do it right now. So you're using those 4 sides, okay? You connect all the atoms with a single bond. So 2, 4, 6. 6 total electrons we need to subtract. So we have 18 electrons left. Those will go on the peripheral atoms, the bonded atoms, until their octets or duets are satisfied. So 2, 4, 6, 8, 10, 12, 14, 16, 18. There are no remaining electrons for that central atom. So now there's 0 left. So we don't have any to put there. Check to see if we need to make multiple bonds. This time we need to do this. Okay, so some of you didn't do that yesterday in the end, because when we look at carbon, carbon only has 2, 4, 6, but it needs 8. All of the oxygens are satisfied. This has 8, this has 8, this has 8. But that carbon in the center is not. So when we need multiple bonds, remember they have to come from the structure. You can't add in new electrons to make it work. So if I want another bond, I will have to remove 2 electrons from one of these oxygens. It could be any of the 3, and then make a bond there. Okay. Then my final step, because this is an ion, is to add those brackets. So the bracket looks like this, and then I'm just going to put the charge up here, 2-. Get rid of this so we can see a little better. Okay. So that is how we do an ion. Again, the only new piece is for the valence electrons, we're going to add electrons if it's negative, subtract electrons from the total if it's positive. And then at the end, we put brackets with the charge. But other than that, all the steps are exactly the same as they were yesterday. So today's a really good day to practice that as well. All right. Want to share something else? We could do one more of these, I think. So hopefully you copied that down. We could do another ion. Maybe we'll do SO3 2 minus. That looks like a good one. And I can post a key of all of these this evening, but I think it's important for you to try it yourself first. Okay. So we have SO3 2 minus. So you will want to get your steps out for the order in which to do this stuff. So it's not at the top of this document. You'll have to use yesterday's document. So each sulfur has 6 valence electrons. Each oxygen has 6 as well. And then the 2 minus means we're adding 2 more electrons. So it became -2 because of that. So 18, 20, 26. So 26 total electrons. I'm going to erase this just for space. My next step is to determine my central atom. It's usually the one that's written first. In this case, it is. And then I surround it by those 3 oxygens. I will then need to bond everything to the central atom, 2, 4, 6, and subtract. So I have 20 electrons left. So I put those around the peripheral atoms until their octets or duets are satisfied. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Now there are 2 left. So because I have some left over, now I put them on the central atom. Some people were putting them on the central atom right away yesterday. You only do that if you have some left over at the end. Then I want to make sure my octets and duets are satisfied. In this case, they are. So I don't need double bonds. I put brackets because it's an ion, and I put the charge on the outside. All right. There's a couple that are 1+. So I guess we could do one of them together. I would like for you to see one before you try to do them on your own. So let's do NH4. Okay. So this one, nitrogen is in the 5th column, so it has 5 valence electrons. We have 4 hydrogens, each with 1. And then 1+, remember, to become positively charged, that means you lost 1 electron. So I will actually subtract 1 from the total. So it was 9, now it's 8 total valence electrons. Okay, I choose my central atom, nitrogen. I surround it by each of these hydrogens. I bond it to the central atom, 2, 4, 6, 8. So that's it, there's none left. Remember, octets and duets are satisfied. You want to make sure of that on the outside. Everything's a hydrogen, so once it bonds, it's happy. The nitrogen has 8. And then, so I just put this in brackets with the charge. Okay, if you have any questions, please email me. If you email me during class, I do check my email obsessively, to be honest. So if you email me during class about a question, it's possible that I could explain it even while you're working on it. But hopefully the video is helpful enough, and you're very, very smart classmates on top of it. And then I can also put just an instructional video made by someone else as well that gives you even more examples if you feel like that you need that. All right, have a wonderful day, everybody. And I can't wait to be back soon. All right, bye, friends.